right, guys, let's get started. I think we waited enough. It's already 16, 17 minutes. Let's get started. All right, good morning, everyone. Let me know if you guys can hear me and see the sublime text. Quickly give me a yes in the chat if you can hear me well and see the sublime text. Come on, guys, be quick. Cool. Why is the batch attendance so low? You're supposed to be 20 to 25 people, if I'm not wrong. Why is the batch attendance so low? Okay, probably will check with your course coordinator, but anyways. All right, let's quickly start with where we have in this batch and those who are joining for the first time. I see some of the new names. So in case those who have not joined in the previous session, let me just give you a brief review what we have done so far. Okay. This is your low-level design course, and this is the second session that we're going to start today. We had one session in the last week. Let's quickly revise what we have gone through that and so on and so forth. This is multiple mixed batches. I believe almost all of you have been taught by me before, either a high-level design course or a DSA course or something like that, right? Might be one or two people who I have not taught before. So this is the low-level design here. Okay. In terms of overall syllabus, what we are going to cover as part of low-level design, we have the requirement gathering, laying down the use case. We talked about the UML class diagrams, which includes four major diagrams: class diagram, activity diagram, use case diagram, sequence diagram. Then understand the difference between object-oriented programming versus object-oriented design. We talked about class and objects, NVIDIA techniques, case study, and creating a class diagram using raw.io. Then we'll try to understand about different class relations, assigning responsibility to classes. What are the different relations between classes, which includes composition, aggregation, association, inheritance, so on and so forth. Abstraction versus encapsulation, converting an object-oriented design to model problem. How do you write a good quality code, which includes design patterns, some best principles like solid, keep it simple and short, dry, and so on and so forth. And finally, case studies, actually writing the code, implementing the solution. This is the overall agenda of how the low-level design looks like. Okay. So if you have to give it numbers of classes, usually 10 to 12 classes, which includes basics of LLD, complete solid, design patterns, case studies. Okay. Initial two classes, I keep it for basics of LLD, class, activity diagram, etc. Next three classes, I keep it for solid principle. Next three for design patterns and next three for case studies. This is usually I try to conduct the sessions, but of course, it depends on how quickly you grasp it and so on and so forth. First thing first I clarified was understanding the difference between a high-level design versus low-level design. So you know what is the scope of high-level design and what is the scope of low-level design exactly. So when we talk about high-level design, we are not talking about any code here. We're talking about just the components which are connected, how they're interconnected, what kind of data flows from what system to another system. Okay. So when we talk about high-level design, we usually follow a top-down approach. What do you mean by top-down approach? We're given a business problem on a higher level. We started drawing, understanding the basic architecture. For example, if I say design WhatsApp, we'll start with the client, we'll start with the server, we'll talk about load balancers, CDNs, etc. We'll talk about multiple services, group service, chat service, user profile service, etc. We'll talk about DB schema. Do we need the data schema? Do we need the table schema, like user schema? What kind of DB schema we need? How do we need that? We'll talk about data flow. We'll talk about caching, analytics, security, etc., etc. Okay. That's how we usually approach it. When we talk about low-level design, the requirements and the flow of approaching that is a bit different. In low-level design, we start with first of all, requirement gathering. Then we go for laying down the use cases. We create UML class diagrams to understand how the components are going to interact, what kind of code is going to be there, how do we write a good quality code. Okay, all of this. So long story short, high-level design, you talk about a business problem, talk about a technical solution for it, nothing related to the code. You just mention what should be the component, what should be the choice of tech stack, what should be the choice of databases, what should be the schema of the APIs, how does the schema of database should look like, so on and so forth. And you provide the reasoning behind it. In low-level design, you go to the code part, you implement all the best practices code that you know in the code, and then you continue from there. I mentioned some of the important resources. So if you want to refer, I would highly recommend these three resources. This book, which is Design Patterns, Elements of Reusable Object-Oriented Software hardcover, this is a really good book. This is written by the gang of four. These were the four C++ engineers back in 1994, written back in 1994. This is a really good book. And even though its book is almost 31 years old now, when it came out, still this book holds a lot of relevance in today's time as well. It talks about 23 major design patterns, and more or less we're using those 23 design patterns, even with few additions and so on and so forth. Okay. Do we need to know all 23 design patterns? No. Are we going to use all 23 design patterns? No. Majorly 9 patterns, 8 or 9 patterns, you can solve 90% of the software engineering problems. We'll talk about it once we go to design patterns. Second book is Designing Data Intensive Applications by Aurelie. This is also a really good book. And if you want to read a website, refactoring.guru is a very good website. Okay. I'll be taking some references from here as well, by the way, once we go to these required places. This was for the low level design. For the high level design, I give you basic and intermediate. So if you're a basic and intermediate, you want to understand with the high level design, I would recommend this book. This is System Design Interview, Volume 2. This is for Alex. This is by Alex, and he also has a blog and YouTube channel called Byte Go. So you can refer some good articles, some good information about the high level design in general there. If you believe that this is too basic for you and you want to become an expert, or if you think you are an expert and you want to target some more high level design questions or target some more real life problems, now you can go to this website called highlevelhighability.com. This is where majority of the architects and lead engineers are. So you can participate in the discussion and so forth. The UI is not that friendly, but you will have the kind of discussion that you're looking for in the threads. All right, let's start with the L&D part that we have done. Number one is requirement gathering. So when we say requirement gathering, that's part of any design, irrespective it's a high level design or low level design. Let's take an understanding. If I get a problem statement like this, build a low level design for a parking lot system, or basically write a code for a parking lot system. Now, why it is important to have a clear requirement gathering? Because your code will change and the way you're going to structure code will change. And the way you're going to design and write the code, that will completely change. So if you do not have the proper requirements with you, there are certain decisions which are one-way decisions, means you cannot go back and change it. Certain decisions are two-way decisions, you can go back and change in the code. But if you don't have this requirement clear, making the change later might not be backward compatible. Okay. So always write a code which is forward compatible and backward compatible. But there are some situations where we cannot have the backward compatibility altogether. Okay. So take an example. What kind of requirements I can clarify when somebody says write code for parking lot system or build low level design for parking lot system? The first question I would ask is whether it's a one level parking or it's a multi-level parking. Then I would ask one type of parking or multiple type of parking, one place or spread across the cities, one user or multiple users. These are the questions that I would definitely ask. Why these questions will make an impact? Take an example. If I don't know whether it's for a one type of vehicle or multiple type of vehicle, and let's say from my assumption, I start writing the code, there is only one vehicle and that vehicle I've named it as car and I'm using it everywhere in the code. Later, the requirements came that you have to extend to multiple vehicles. If I knew about that, I would have probably kept an enum and I would keep on adding it to the car. Now, what this will require is I will need to create another vehicle or another variable, whatever you want to name it, and then you have to replace all the occurrences of this vehicle that you have used in the code. And that will change the entire structure of your code. Okay. So it's always good to have a clear requirement and also think about the future use cases. That's what we call as forward compatibility. Okay. Extensibility of the code. Then we talk about laying down use cases. So in terms of laying down use cases, we have every stakeholder, which we call as actor, will have their use case in the system. Example, first identify in a system who are the stakeholders or are the actors and what will be their specific use cases. Take an example of online banking or net banking. What on a higher level, what can be the stakeholders? The stakeholders can be a customer, it can be a bank employee, it can be admin, or it can be external system. Now, what is customer supposed to do? What are their use cases? Customer can check balance, they can do transactions, they can use whatever features in that. What about bank employees? For example, there is any query, there's any problem related to a transaction, bank employees can help them resolve. Inside the bank employee also, there will be admin and node admin. So this is I'm talking about non-admin usually. For admin, they would have the capability, they can lock or unlock somebody's account. And then comes the external system like third-party systems or approvals and so on and so forth. So these are overall the stakeholder that we have in a banking. Why this is important? This is important from multiple purposes. Number one, when you'll be creating a class diagram or activity diagram or sequence diagram, you will know all the stakeholders in the system at one place. Because first thing is you will have a diagram that will get approved, updated, approved, whatever flow it goes. And finally, on basis of that diagram, you will be starting writing the code. Okay. So this will help you document every major stakeholder and then you can document it accordingly. Now, we talked about UML diagrams, the types and purposes. So we talked about on an overview level, what is a UML diagram? It's a unified modeling language. Now, the word unified says a lot of things here. Why? It is not specific to a tech stack. It is not specific to a language. It is unified. Unified means irrespective, I give you requirements, irrespective whether you're going to code in Java, Node.js, Python, Golang, or whatever language that you want to code in, the requirements will remain the same. The UML or the diagrams of the UML, that will remain the same. That's what is called unified modeling language. What's the purpose? The purpose is whatever requirements you're given in terms of low-level design, you convert those into diagrams. Okay. Overall, UML diagrams are categorized into three categories: structural, behavioral, interaction. We discussed about all of that. I've explained the images. Out of those, the important ones are class diagram, activity diagram, use case diagram, sequence diagram. We have discussed all of this in detail in the last class. Okay. I've shared the diagram, so it should be in your wherever the notes are provided to you. I think it's LMS portal, you'll find it there. Okay. Now coming to the class diagram specifically, and we did a case study for that as well, that will continue for today as well. How do you usually write a class diagram? You mention the class name, you mention the data members, only which are useful. You don't need to mention every data member, right? You mention the form name and the return type. For example, name and string. Member functions usually, which is no constructors, getters, or setter, important function which define the functionality of a class. Okay, that's what usually we keep in a class diagram. Now, then we talked about classes versus objects. Haven't got the notes and diagrams of last class. You can follow with the course coordinator. They probably would have updated, or maybe you don't have the access to it or something like that. From my end, I have provided them, so you can follow up after the class. Okay. Now, coming up to the classes versus objects, that's the next topic we discuss. First thing first, we have to understand programming was not always with classes. It's not like since the inception of programming, we have the classes and we have everything, we have object-oriented programming, nothing like that. Programming has evolved over decades and it has changed the way that we write code versus what we used to write in 1970s. Okay. So before class was even a concept, we were still doing coding. That time there was something called structure. Okay. The structure was really good because you can have multiple different data types. You can have integer, string, or whatever data type you want. But it can only contain the data members. It cannot contain the functions. Okay. Functions were separate. We used to call the constructor. There's no thing called constructor. We used to call the functions to pass references of the struct variables. Okay. From the struct variables, we can change the behavior as we want to. And that was a difficult part because data members are completely separate and member functions are completely separate. When class was invented, the whole concept of bringing data member and member function under one umbrella came into the picture. That's what exactly class is. So the first language in the world which introduced a formal concept of class, that was C++. It was initially called C with classes for a few years, then it was renamed as C++. Okay. The person who developed C++ was Bajan Strausstrup. It was developed in 1979. What did he exactly do? He looked at the problem statement and understood if instead of using it in a different places, data members separately, member functions separately, what if we combine them together under one umbrella and solve the problem statement? Then it will become easier. From the same object or the same reference, I can access the data member, I can access the member functions. Okay. So that is when the concept of class came into picture. So data members and member functions clubbed together. You can have the property as well as the behavior. So that is how you can create an object. From that object, you can call a function, you can call a data member. Then we talked about object-oriented programming versus object-oriented design. So what's the difference between that? Let's try to understand. When we say object-oriented programming, we are talking about the four main pillars of object-oriented programming, which includes inheritance, polymorphism, encapsulation, abstraction. I believe all of you know this by now, but even if you don't, we are going to discuss that a bit later. Here's the difference between OOPS versus object-oriented design. So if we are following these principles, inheritance, polymorphism, encapsulation, abstraction, and we are coding in such a way that we are following that, we call it as a object-oriented features, right? This function programming doesn't necessarily have to follow the object-oriented thing. So object-oriented and function programming are two different things. What is object-oriented design? Object-oriented design, as the word itself says, it's a design, not an implementation. This is an implementation. Design means we want to model a real-world problem using the object-oriented design technique. What does that mean? Can I use the object-oriented programming without object-oriented design? Yes, I can program the way I want. But can I use the object-oriented design without object-oriented? The answer is no. Okay. My object-oriented programming can be done while violating the object-oriented design principle. Other ways, not at all. Okay. For example, if you have to give a real-life example to understand, if I'm driving, that is object-oriented programming. It's up to me how do I want to drive. If I'm overtaking it, that's an object-oriented design. You cannot overtake without knowing driving, right? So you have to know drive first in order to know whether you overtake or not. Then we move to classes and objects. As we discussed, class is a blueprint, a template of object. This is not a real world entity. Object is an instance of a class. Object is a real world entity. Okay. Example, real life example. If I talk about blueprint of a compartment of a train, I'm referring about a class. If I talk about actual compartment of a train, I'm talking about an object. Then we move to the code part. We have the class employee. Let's talk about it. In the class employee, I create an integer array of value, new integer 100, integer value 2. Until this part, what is the size of employee class in bytes? Until this part, it is 0 bytes because I have not created any object. The moment I'll create an object, that is when I'll know what is the size. This is 100. plus 1, which is 101, into 4 bytes, which is 404 bytes. Okay. It's very basic interview question. I don't think we usually ask to senior folks, but this is a very basic interview question. So be mindful of that. Anyways, class is a combination of data members per member functions. When we say data members, that is where we store the actual information. Okay, attributes, data variables, constants, enums, etc. Those are your data members. When we talk about member functions, we're talking about specifically the properties or the behavior. That's what we call for functions. A real world scenario, let's talk about it. If I talk about a class car, what attributes you can denote with the class car? We can have a wheel, it can have a color, it can have an engine. And we talk about behavior, it can accelerate, it can drive, it can stop, so on and so forth. Okay. Then you can create an object like this. Another example, if I create a class human, my attributes can be height, weight, my behavior can be they can walk, they can talk, so on and so forth. Okay. Then we finally move to a good technique called the NVT technique or NVT trick. What is this NVT technique or trick? Let's talk about it. NVT is simple, noun, verb technique. Whatever you have learned in English, same thing, noun and verb. What is that denoting is, if you are given a problem statement, usually, if you're given a problem statement, whatever is the noun, it will actually go for a class or it's referring to a class. Whatever is a verb, which is denoting a behavior, that is what you call as behavior of functions. Okay. Although when you read the problem statement, you will have a better understanding which should be a class, which should be a function. But in case you feel like you're stuck, you're not able to differentiate, then this NVT technique will be useful to you. Okay. To understand that, we did a case study. The case study was, we have a Udemy classes case study. So I talk about the problem statement. These are the 4 statements. I mean, this one problem statement, just 4 lines. So user goes to the website, select the batch slots for the course he or she wants to enroll, add them to the cart, check out and make the payment, confirmation of course is being enrolled. Now, in this case study or in this problem statement, just highlight which one are the classes, like which one are the nouns and which one are the verbs. Whatever are the nouns, they are the classes. Whatever are the verbs, they are the behaviors of function. Okay. So let's start one by one. When we talk about noun, user, batch, courses, cart, payment, they all are noun. And when we talk about behavior of functions, select the course, add them to cart, check out and make payment, courses being enrolled, all of these are behavior of functions. Okay. We have done the case study based upon the class diagram that we've done on raw.io, and that's what we have continued so far. Okay. I'll quickly show that as well. Let me quickly share my screen. This is what we have drawn till the last part. Okay, this is what we have drawn. Problem statement, how do you create a class diagram? These were the 2 class diagrams we have created, user and cart. Okay. All right, let's coming back here. This is what we discussed till the last class. Quickly give me clear if everybody clear with the revision so I can start with today's session. Come on guys, be quick. Quick. Okay. To answer your question, C is procedure-oriented languages while C++ is object-oriented. Okay. One moment, guys, one moment. C++ is object-oriented programming versus difference between. Okay. Understand. The concept of object did not even originate if there was no class. So C can never be object-oriented programming in the first place. The concept of object or classes initiated after the classes were introduced, and that was in C++. Part 1. What do you mean by procedure-oriented languages? See, you have to understand. In the earlier times in the sense when you used to code in Pascal and other languages, COBOL, Basic, Pascal, in those languages, everything was a procedure. Okay. So you give one instruction, that instruction works, you call it as a procedure. So that's what we call as procedure-oriented languages, which means you pass a sequence of instructions or sequence of steps, whatever we want to call it, and that will be called as one procedure. So let's say 5 instructions set as one, that goes as one procedure. So sequentially, everything will happen. There is nothing a part called object, there's nothing principal designed for it. That was initially the code for all the languages, procedure-oriented languages. When C++ came into the picture, it pretty much changed everything. It introduced the concept of classes, introduced the concept of objects, and introduced the pillars for object-oriented programming. When we follow that pillars, that's when we become object-oriented programming specifically. Later forward to next 20 years, then the functional programming came into picture. So it denies the principles of object-oriented programming. It only works upon the functions. Everything can be a function based. Okay. That's how the 3 major categories, POP, OOP versus the functional programming. Okay. Hope that answers your question. Function-oriented programming. See, in function-oriented programming, we may or may not have to follow the pillars that is developed by the object-oriented programming. Function-oriented programming means You do not necessarily need to have classes or objects. You can just work on the top of functions. You can define the global variables, or you can pass the variables by reference to a function. You do not need to necessarily create an umbrella called class or whatever you want to call it just to access those data members. That's what function oriented is. The purpose of function oriented is everything can be done lean without having too much dependency on the abstraction of the data. Okay. To the previous question, difference between activity and sequence diagram. See, sequence diagram just talks about on a higher level, what are the different stakeholders, or not even the stakeholders, what are the different systems which are involved in our diagrams, okay, or involved in our system, and how the data is flowing from there. It just talks about the sequence of activities. Activity diagram is a detailed diagram. It talks about each and every flow. So, for example, I think I gave the example of order creation. What happens if the order get created? What happens if the order get cancelled? All the flow charts, all the parts will be part of the activity diagram. That's a detailed part of it. In sequence diagram, we don't talk about the flow chart usually. We don't talk about the if-else scenario. We talk about what are the different systems involved and how do we interact with each other. That's what sequence is. Okay. All right. Any more questions? Come on, guys, be quick. Golang. Golang is one good example. Rust is one good example. Okay. That's why there is no concept called classes in Golang. Okay. All right, guys. Any more questions? Anything that you need more clarification as we can start with today's session? Cool. All right, guys, let's start with today's session. Let's talk about something interesting. Then we'll go to case studies again. Let's start with the relations between classes. Okay. Let's try to understand. We know what is class, we know what is objects, we know about object-oriented programming. Let's try to understand this topic called relation between classes. What kind of relation we can establish between the classes and why it is important to understand those relations one by one. On a higher overview level, you can have either a has a combination, can be composition, can be aggregation. We'll talk about these terms. Or a is a relation, which is inheritance. Inheritance, I believe everybody already know by now. It's part of the object-oriented principle as well. You have a parent class, you have a child class, or you have a base class and derived class, whatever you want to call it. Apart from that, if the relation does not qualify in a has a relation or is a relation, then we name that as composition. Okay. Association generally. Apart from has a relation and is a relation, relationship, that is what we term as association. Okay. So has a relation either can be composition aggregation. We'll talk about it in a bit. Is the relation inheritance? If between two classes, it neither qualifies under the umbrella of a has a relation or in a qualify for is a relation, then we'll just qualify it for association. Okay. It's not necessary that every two classes has to be associated with something. It's not mandatory, right? There might be two different classes which has nothing in common. They might not even interact with each other. Okay. Now let's try to understand this. Relations between different classes in our system. Relations between different classes in our system. Number one, association. Number two, composition. Number three, aggregation. Number four, inheritance. So composition is has a, aggregation is also has two types, whether composition aggregation. Inheritance is a. Okay. Association is neither has a or is a. Okay. Now let's try to understand these terms one by one. What does composition means? What does aggregation means? What does inheritance mean? Then we'll talk about association. Okay. We'll start number one. Association. What does the word association means? When do we claim that two classes are associated with each other? Let's talk about that. Association is a structural relationship in a system in which different objects, here when I say objects, I'm talking about components. I'm not talking about class and objects. Okay. Different objects are linked within the system. Structure relationship in which structure relationship in a system in which different objects are linked with each other. Okay. Represented by a line between classes. We'll talk about it. Following an arrow that navigates the direction. Okay. Represented by a line between classes following an arrow that navigates the direction. We can specify the cardinality or the multiplicity of an association. And it exhibits a binary behavior. Okay. When I say binary behavior, it means it has two types. Let's talk about it one by one. I'll go through these statements first. It's a structural relationship. So it just talks about the structure of the classes, how they're connected with each other. Represented by a line between classes following a direction, arrow that navigates the direction. We'll go to the diagram and understand that better. But just to tell you, how do we show that it's associated, whether in a composition or be in aggregation, we denote it by the direction of arrow. We can specify the cardinality. What does cardinality multiplicity means? How it is connected, whether it's a 1:1 relation or is n:1 relation, so on and so forth. Exhibits a binary behavior means there are two types. Okay. So association can be divided into two parts. What are the two parts? Composition or aggregation. Okay. In both the cases, at the end, they all are part of association. In both the cases, object of one class is owned by object of another class. The word own is important here. Okay. So either you talk about composition or you talk about aggregation. In both the cases, object of one class will be owned by the object of another class. Now, what's the difference between them? The difference is, in case of composition, the owned object does not exist independently. Okay. In the case of composition, the owned object does not exist independently. In case of aggregation, the owned object does exist independently. Okay. There's a difference. So when we talk about composition and aggregation, so in the common thing between composition and aggregation is object of one class will be owned by the object of another class. That is going to be the common thing. The difference is when we talk about composition, the owned object cannot exist independently. So if there is no object which is owning it, the owned object cannot exist. In case of aggregation, even if there is no object which is owning it, the owned object can exist independently. We'll understand this with an example. Okay. Just on that note, aggregation is a special form of composition. And composition is special form of aggregation. This will be association. Okay. So now Venn diagram, it looks like this. Superset association Inside that you get aggregation. Inside that you get composition. This is how your diagram looks like. So let's make a Venn diagram to understand this better. Here it is. This is your superset. This is what you call as associations. Okay. In the association, you have aggregation. Association, aggregation. So all aggregation will not be all aggregation will be association, all association will not be aggregation. Inside aggregation, you will have the composition. Okay. This is how the Venn diagram looks like. So all compositions are aggregations, all aggregations are association. Both aggregation composition eventually are associations. Okay. So those class relationship which do not qualify under these two categories, they qualify under this category. Okay. Let's clear this. Let's understand this with an example. We'll be much clear with that. Okay. Now, let's decode the first kind of relationship. One more. Association doesn't have a has a is a relationship. So are the composition aggregation part of association? Yes. Composition aggregation are part of association. It's all a has a relationship. Okay. Association we don't name as has a because that's what I said. If does not need to be mandatory, the two classes has to be connected. There are two completely independent classes without any relation with each other. They still will be called an association. Association is the larger umbrella. Inside that we have composition and aggregation. Okay. So let's start with has a relationship first. Part one, aggregation. Aggregation is also has a, composition is also has a, association we do not need to classify as a has a. Okay. Now, what did I talk about here for a has a relationship for aggregation? For aggregation, I said something. The owned object does exist independently. So two things. In case of aggregation, there will be a class which will be owning the object of another class. All agree? Come on guys, quickly in the chat. There will be an object which will be owning a class of another object. Part one. Yeah, that's what I'm coming to. Let me go to the example. It'll make more sense. Part two, the owned object does exist independently. Okay. Let's take an example. If I have a class cart and if I have a class let's say courses. Now, when you add courses to the cart, so who will be owning which class? Will courses own the cart or the cart own the courses? Quickly in the chat, guys. When you add courses to the class, does class own the cart? Does course own the cart or the cart own the classes? Come on, guys, quickly in the chat. Correct. Cart will own the courses. Let me put it here. Cart will own the courses, of course. Okay. That's what the relationship has a cart has a course. Even if you read the relationship, that will make much more sense to you. Cart has a relationship. Simple thing, right? Important part is what kind of has a? Is it the aggregation or is it the composition, right? Both aggregation composition will have a has a relationship. A has a B, but the difference will come whether B can exist independently or B cannot exist independently. Repeating my words, both in composition aggregation, it will be A has a B. A is the class owning it, B is the one which is being owned. The difference between composition and aggregation will come if B can exist independently or not. If it can exist independently, it's an aggregation. If it cannot exist independently, that is a composition. Okay. Now understand this. When I say cart has courses, it is 100% clear. It's a has a relationship. Okay. I have denoted the arrow also. Now the question becomes, can a course exist without adding to the cart? Yes or no? Can a course exist without adding the cart? So if there is no cart, can a course exist? Of course, a code can still exist. So even without a cart, my course can still exist independently. And that is why it becomes an aggregation. Okay. That's one example to clarify it. Another thing that I mentioned about, if you look at this, we can specify the cardinality or multiplicity of an association. What do you mean by cardinality? Cardinality will denotes what should be the cardinality or composition, code segregation. No, we are denoting between two different classes. Okay. Now, when we talk about cardinality, we are talking about the relationship. So what should be the number, whether it's a 1:1 relationship, whether it's a 1:1 relationship, so on and so forth. Now you guys tell me, can a card contain only one course or can a card contain multiple courses? Correct. So this will be 1:1 cardinality. Okay. In the diagram, we represent like this, 1 dot 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 star. Just to mention here. This is how we represent the diagram. Once we go to the diagram, we'll talk about it. Anyways. So first, card can have multiple courses, part number 1. So my cardinality becomes 1:n. Let me mention that in the brackets. Cardinality becomes 1:n. Second, even without a card, my course can still exist independently. Okay. Any doubt in aggregation, let me know. If it is clear, just type clear on the chat. Then I can start with composition. Clear? Easy? Cool. Second kind of has a relationship that we have that is called composition. Okay. Again, both aggregation and composition will read A as a B. The only difference is if B exists independently, becomes aggregation, cannot exist independently, will become a composition. That's what we are going to check now. Okay. So let's take an example. I'll make this as customer. I'll make this as credit card. Now understand something. Can a credit card exist without a customer? Can a credit card exist without a customer? You cannot have a credit card without a customer because how would you set the limit? You need the credit history and all of that, and credit card are mapped to a customer. So without a customer, my credit card class cannot exist independently. It has a dependency. It should be a customer, and customer will drive the credit card. Okay, so on and so forth. Next question. So first, it becomes a hazard relation. Customer has a credit card, as I said. So both of them will look the same. Card has a course, customer has a credit card, so on and so forth. Now the question becomes, can a customer has, or what should be the cardinality of these classes? Can a customer has only one credit card or can a customer have multiple credit cards? Come on guys, be quick in the chat. Of course, they can have multiple. So what's the cardinality we're talking about? 1:n again. Okay. Goes without saying, diagram will be like this, like this. Okay. So customer can have multiple cards. Customer can have multiple credit cards. That's why it's a 1:1 relationship. And credit card cannot exist independently. That's why it is a composition. That's it. Okay. This was the idea here. Then moving to next. How and where cardinality helps. Okay. How and where cardinality helps? Number one, it's very useful in terms of documenting it while you're creating the data flow. It's important to mention about what can be the separate dependencies. Number two, where in terms of code, how you're implementing it, I won't say much decision is done by that, but the way you're implementing it can finally decide it, right? For example, if I have to create class credit card, the way I will be writing a credit card, I will be creating a mapping that I can create multiple objects of credit card, which can point to the same customer. So just an example. If I have to give an example, if I have to write a code for this credit card, I will create a dependency like this, implements I customer. I'll create the interface for a customer. In that customer, I'll pass the customer ID. In this credit card, I'll keep a customer ID. So I can keep what's the customer ID attached to a credit card, and whatever credit card, let's say I can extend this credit card into multiple credit cards like bank, Visa, MasterCard, whatever that is. So those, all of them will carry the property of that customer ID. That's how it is useful. It completely depends on developer, how they implement it. Definitely for the diagrams and also for the code part, however you want to implement it. You can implement by interfaces, you can do it without interface, you can do it by abstract classes, however you want to do. I'm not commenting on that, but it's important to know what's the cardinality of the classes you are dealing with. Okay, cool. That was the second part. So we talked about two has a relation. One was aggregation. We talked about aggregation in detail. We talked about composition in detail with a real life example. Now let's talk about the third relation, which is a relation. Is a relationship is inheritance. We know that. And to understand that, let's take a simple example for inheritance. So I'll take the same as we are making it. We have courses. Let's make any specific type of course, which is LLD course. Now, if you look at this, course can be considered as a parent class, and LLD is just one type of that course. Agree? Course overall is a parent class. LLD is just one type of course. This is what we call a is-a relationship. Okay. Now, the question becomes cardinality. Can a course have only one LLD course, and can a course have multiple LLD courses? Yeah, coming to association, let's finish this first. Come on, guys, be quick. Can a course have just one LD course, or can a course have multiple LD courses? Why 1:1, guys? Courses can have anything, right? If I have a parent class course, I can have LLD, I can have HLD, I can have whatever course I want. So it is 1:1. It's not 1:1. Okay. In this case, my parent child is course and parent class, not parent child. And my child class is LLD course. So if I have to write a code, how will I write the code? So I write the word implements here the way I want to implement it. If I have to write it here, everybody knows the code of inheritance. How does it look like? Class LLD course. What's the keyword we use? What's the keyword we use, guys? Quickly in the chat. Here's the keyword that we use for inheritance. Correct. The keyword is extends. Extends for inheritance, implements for implementation, whatever kind of relationship you want to implement. Okay. All right. Can we combine these two? We can combine these two as well, by the way. Okay. Now, I'm going to do two things. First, understanding using diagram. And second, we'll do it with a case study. So I'm going to take you to draw.io. We'll continue from there. Understand using diagram and doing the case study. Then we'll talk about association as well. Okay. Association in general, whether it's not aggregation or composition, it means two classes which are necessarily not connected. That's it. So we don't qualify it under has a category, and obviously it's not a is a category. So these two classes would just not have any relationship altogether. Okay. But before I take you to draw.io and I continue, let's clarify and let's quickly revise what you've done till so far, and then we'll take it from there. Just give me one moment. Okay, cool. Coming back. So relation between classes is aggregation commercial parts. Yes, that's what I said. So relationships, that's what I'm completely revising. Let's revise one by one. So a relationship can be a has a, or it can be is a, or it cannot be a has and is a. Okay. Has a relationship includes composition and aggregation. A has a B. Is A is a B. And between two classes, there might be a relationship which does not even has or is a. So you cannot clarify as a as a B or B as a B. Okay. So neither has or is a relationship. So we have association, composition, aggregation, inheritance. If I talk about association in detail, it just talks about the structural relationship, right? How the objects are linked in the system. We talked about how do we create the line. We talk about the arrow navigation, so on and so forth. We talked about cardinality and multiplicity of an association. Exhibits the binary behavior means Association we can further divide into two parts, composition and aggregation. If it's not of these two parts, it can still be an association, means two separate classes which do not have any kind of relation between them. We still call that as association. Okay. Now, in both the cases, both for composition and aggregation, object of one class will be owned by the object of another class. The only difference is when we talk about composition, the owned object does not exist independently, but in the case of aggregation, owned object does exist independently. Now, aggregation is a special form of association, composition is a special form of aggregation. Okay, we talked about the Venn diagram here. Then we move to the real life example to understand. If I talk about aggregation, means even without the owned class or the owning class, it can still exist. The owned class can still exist. So if I talk about aggregation, if it's a has a relationship, my cart can exist. Even without a cart, my course can still exist. That's why it is aggregation. Now, coming to the cardinality, a cart can have multiple courses. That's why the cardinality is 1:n. Another example, which is of has a relationship, which is composition, means which is my own class here, credit card. Now, my credit card cannot exist independently without a customer. That's why it becomes composition. And my customer can have multiple credit cards. Okay, so cardinality becomes 1:n. Then we move to the next part, which is a relationship. That is what we call as inheritance. So, is a class courses, there's a class LLD course. Parent class is a course, child class is a LLD course. LLD course. Okay. So I can extend from my parent class and I can extend it to my child class and I can transfer the properties there. That is overall the gist of whatever we have discussed so far. Now, let's take it to, yeah, I'm coming to it. I'm coming to it. That's what I said. I'll take it the example in draw.io. So let's take an example. Let's move to draw.io and let's start drawing there itself. Okay. Let's move here. Let's come here. Okay. All right. Let's try to quickly make diagrams here. So first thing, what do I want? I want a class diagram. So let's see. Do we have a list of class diagram? We should. Come on, we should. Not the basics, UML and UML. I want a class diagram. This should work. Okay, let's talk about it. Copy this, paste it here and make two classes. Let's start one by one. In general, any relationship between two classes, it starts with association. Whether it can be dropped down into aggregation or composition, that's a separate part. But in general, everything will be association in the first place. So whatever these classes, let's call them as association first. I'll take one as teacher, one as student. Okay. Let's keep the field and type. Nope, I'm not saving it. Let's keep it as name, type to be string. Let's keep it as email, type it to be string. And let's put something called class taken. Class should start with gaps. And that's returning me a number. Simple things. Few data members, few member functions. For a student, let's keep the name as string. Let's keep the marks as number or integer. And what else? Let's have, no, let's have eligible for eligibility check or whatever it is. For exam, let's keep that as void. Whatever basis we want based upon attendance or marks, whatever that is, we can keep. Okay. So we have two classes. We already know how to create a class diagram. We have two classes. There's a teacher, there's a student. It is by default association. Any two classes by default association. Now it can be composition, can be aggregation, or may not be composition or aggregation, but by default they're associated. Okay. Now let's try to understand what kind of relationship we can talk about here if we can further drill down in terms of association. It is many ways association. Now, can a teacher, let's first connect them together. Okay, let's connect them together. Now the question becomes, can a student exist without a teacher? Can a student exist without a teacher? Okay, I got conflicting answers. Can a student class exist without a teacher class? Come on, guys, be quick in the chat. What about the other folks? 5 more seconds, be quick. Okay, I got two no and I got two yes. See, I think I get why some people are saying no and why some people are saying yes. Let me clarify in the context I'm asking it. I believe the people who are saying no is because if there is no teacher, there is no student. You're considered to be a student if you have a teacher teaching you something. I think that's what my understanding is. Feel free to correct me if there's some other reasoning behind it. It's one way of looking at it, but if you look at it, if a student is enrolled in a class and they do not have a teacher associated at that moment, let's say there is no teacher associated, but they're still a student. Agree? Let me repeat myself. If a student is enrolled in a class and let's say for a moment or a substitute teacher, whatever the teacher is, there is no teacher as of now, but the student is still a student of that class, right? So student can exist without the existing of a teacher. So I'm not asking in the literal way, like if there's no teacher, there's not student, not in that sense, but in the sense, think in a real life example, a student is still a student. It's an individual identity. It's an individual class, right? It's an individual identity. It's an individual class that can still exist. And then a teacher can be allocated to that. Okay. That's part one. So does it become composition or does it become aggregation? Come on, guys. Does it become composition? Does it become aggregation? Quickly in the chat. We just discussed it. All agree? Becomes aggregation. So we start with association, then we move to aggregation. Simple. Okay, by default, it will always remain association, no doubt. Now, second part about the cardinality. What do you think should be the cardinality of it? Can one teacher have multiple students? Can one teacher have multiple students? Quickly in the chat. They can. So what do we denote? We denote 1 is to n. How do we denote in the diagram? We denote it like this. 1 is to star. Means 1 is to many. Same on this side. Can a student have multiple teachers? Can a student have multiple teachers? Yes. So it is 1 is to star again. That is how we create a class diagram in general. You create the class diagram, you talk about the important data members, the important member functions, you talk about the relation between them, and you denote the cardinality. That's it. Okay. Just an exercise to prep you. Although very rarely, if you talk about interview perspective, no, from interview perspective, you will not be asked this question. 99% you will not be asked this question. Okay. Right, to draw the diagram, something like that. But again, the course is not about clearing the interview or just clearing the interview. The course is about becoming a good engineer. Somewhere, once you become senior enough, or depending upon where you're in your career trajectory, you will be taking this ownership to creating it and setting it up from scratch. When you're working on a product from scratch or any particular feature from scratch, you will need to put those diagrams together. And in that case, it will be helpful to know that. Okay. All right. That's one. Now, number two, let's talk about a case study as I was mentioning. Okay. So I'll take one more thing. Any doubt in this? Is this part clear? Is this part clear? Any doubt in this? Any questions? Good. Now let's move to the case study. We can take a case study. We can create multiple classes. One moment. We can create multiple classes. From that multiple classes, we can try to identify what kind of relationship should exist. Okay. This guy here, let's talk about it. Let's bring it a bit more down. Looks better here. So here composition does not exist. Could you please give an example of composition? We talked about composition like class and credit card, customer and credit card. So If there is no credit, there is no customer, there is no credit card. That was example of composition. Okay. All right. Let's start with this one by one. So I'll start with few more classes. Nope, not the flowchart. I'll start with classes. Yeah, you can consider many example. Think of like a dependency. Wherever there's a dependency, all of that are actually compositions. Okay. Class diagram, not this, but okay, we can take it here. Class diagram one, or let's name it first. Let's take it as customer. In that customer, let me create few field, name and string. So what I'm going to do as part of the case study, I'll create few classes and then I'll give you guys time. You guys tell me which class has which relationship with each other. Is a has a relationship, is a relationship, or it's not a has or is a relationship. Okay. That's what I'm talking about the case study here. So name string, let's put one more email. Can we extend it? Yes, we can. Good. Email string. Method, I can just keep a checkout. My customer can check out. Okay, copy this, paste it here. Then you can have a credit card class. You can keep the details whatever you want. I'm not interested in that. Credit card, you can have number, expiry, etc., etc. And payment or whatever you want. Get limit, anything like that. Okay. We got customer class, we got credit card. Nope, nope, nope. We got customer class, we got credit card class. What else? What else? What else we need? Let's take one more. Let's call it as card. Card, you can decide whatever values. Name doesn't make sense. Total amount, total items. They all should fit within the range of integers. And card can have functionality checkout, which is fine. What else? Let's make one more. Payment. Payment, I can give the total amount for payment, and I think that should be fine. And payment method maybe something like this. Okay. All right. This is what I have created. Let me see if everybody can see it now. Zoom this a bit. Everybody can see the four classes. I just create simple four classes: customer, credit card, payment, card. This part clear to all? Everybody can see the four classes. Feel free to change the functions, member function, data members. I'm not interested in that. You can assign the individual responsibility. You can do that. On overview level, I want you to create a kind of understanding what should be the relationship between these classes. For example, what should be the relation between customer and credit card? Is there is a has a or a is a? What should be the relationship between a customer and a card, a customer and a payment? There might be few classes or combination of classes which it does not have any relationship. Neither it is a has a nor it is a is a. Okay. Those are called associations. By default, it's an association. Okay. So if it doesn't qualify under composition, doesn't qualify under aggregation, anywhere it's an association. Okay. So these are the four classes in front of you. I want you guys to come up with the answer that, let's say an example, customer has a credit card or customer has a payment. Give me the relationship that this relationship has a relationship between class A and class B, and this relationship is a relationship between a class A and class B. Requirements clear to all? The requirements crystal clear to all? Any doubts in the requirement? Any doubt which is not clear? Let me know. Okay. If requirements are clear, those I have already taught, you guys will already know, but those to the people I have not taught before, how we conduct, like once I ask a question and I want everyone to reply, I don't want you to be disturbed by other people answer and vice versa. So what we conduct is, I'll ask you to change your message directly to me. Zoom provides you option in the chat. Instead of messaging it to everyone, you can directly message to me. So I'll start your timer, whatever time you need. I think 2 minutes should be more than sufficient. Think about it. Reason scenario, 2 minutes should be sufficient for this one. Once you guys are done, just mention me in the chat that you are done, then we can have a discussion. So answer. So I'm expecting answer like at least 4 answers from everyone. So customer credit card payment, payment card, customer card, or whatever combination that you want to make. Okay, whichever looks reasonable. It's not like since it's 4 classes, so I have to make 4 square combination. Nothing like that. You don't need to think what makes sense. Like customer has a credit card is the easiest way to start with. So start with that, then think what should be the flow, how should I connect one class to another class, and is that relationship making any sense or not. Okay, so I want answers from all of you. We are around 11 folks in the chat. I want all the answers from all the 11 folks. Let's see who will give the correct answers. Please change your message directly to me. Do not message to everyone. Okay. Your time starts now. Once you guys are done, all you guys are done answering, just let me know done in the chat, then we can have a discussion. Okay. Your time starts now. Please change your message directly to me. All right, guys, shall we discuss the answer now? I think I pretty much got the answers from all of you. Anybody who needs more time, let me know. If not, we can discuss now. Cool. Cardinality is fine. I'm not concerned about cardinality. That's something you can figure out. More concerned about the type of relationship. Okay. Last 5 seconds. If anybody is still typing, then we'll discuss. Come on, guys, be quick. Okay, enough time. Cool. Let's start discussing the answer. Let's make the basic kind of relationship. We don't need all kind of relationship by the way. Okay. First thing first, let's start with customer and credit card. I think everybody would have got that answer. I don't expect anybody would not have got that answer. So, customer and credit card, what kind of relationship? Correct. It's a hazard relationship. Okay. We already talked that example. You can message to everyone now, completely fine. Customer and a cart, what kind of relationship? Come on, guys, be quick. Customer and a cart, what kind of relationship? Again, a hazard relationship. Let me, nope, 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 not this guy. Can I take this? No. Okay. From bottom. This is also has a relationship. Okay. What else? This should be fine. What else? A credit card and a cart. A credit card and a cart. What kind of relationship? Come on, guys, quickly in the chat. Is it a has relation? Is it a is a relation? Does it make sense? Read about it. I think it's very easy if you read about it or try to pronounce it. Credit card has a cart. Does it make sense? Credit card has a cart. Doesn't make sense. Credit card is a cart. Doesn't make sense. So what is it? It's no relation. So you can just type it as incorrect, or you can just type it as normal association. It's not necessary that every class has to be related with another class. It's not necessary at all. Okay. Let me write incorrect or just association. That's it. Okay. Cool. Similarly, credit card payment, you can make the things for it, but I have to give in the example that I have to. Okay. Credit card and payment. Let's think about it. Credit card and payment. Mm-hmm. Is it a has or is it a is a? Okay. Think about it. No relation. See, depends on the way that you are looking at. See, if you have to do the payment, is credit card one type of payment? Yes or no? Isn't credit card one type of payment? Think logically in a real world scenario. If you want to buy something, whichever platform it is, you go to a cart, you get a system for payment. Now you can have multiple ways. You can pay by credit card, you can pay by debit card, you can pay by UPI or whatever else you want to pay with. So if I take payment as a class, will credit card be a child class? Yes or no? Correct. So that is your is a relationship. Okay. In this diagram, we have covered all kind of relationship. We have covered composition, we have covered aggregation, we have covered association, we have covered the inheritance as well. And that's the kind of case study I wanted to take. You can create multiple examples, you can try to figure out, but that's majorly I wanted to take. Everybody is still clear with the relationship between classes? Give me clear in the chat. Come on, guys, be quick. No relationship between cart and payment. You don't need to. Don't need to. That's what I said. It's not mandatory to have a relationship between every class in the system. Card and payment doesn't make a relationship. Will it be invoking the class? That's a different part. But does it need a relationship? No. Cool, guys. Everybody clear? Credit card is a payment. In this case, payment becomes parent. Yes, payment is parent. So when we denote, one moment, when we denote a relationship or when we denote inheritance specifically, the arrows are reverse. So the arrows point from the child class to the parent class, not the other way around. Okay. Considering here it is credit card, so it is makes as a, since we got not segregated. Considering here it's credit card, so it makes a has a. No, customer and credit card, that has a relationship. Payment and credit card is a relationship type. These are two different things. Relationship are between the classes. For a credit card, I cannot define has a or is a. It depends on which class context I'm talking about. So the same class can have a has a with another class, can have a is a with another class. Okay, something like that. Credit card, we have specified concrete credit card payment. Specify concrete credit card payment. Now, I'm just taking an example. If you're doing the payment by credit card, this is one form of the payment. That's it. In this case, payment becomes parent. Yes, payment becomes parent. Okay. Can we use both of them together? Can we use like association or an inheritance together? Yes, we can use both of them in the code. So I can share the example here. If I have to give you the code example. Coming back here, this is how you can do. So customer payment credit card. If I have to implement by code, what will I do? Class credit card, do what? Extends payment, implements by customer. We can do both together in the code. Okay, so we can take the properties from the parent class and we can implement it in the function, whatever you want to implement. Okay, association and inheritance can exist together, and they do exist together. You will find such kind of code quite a lot of times. A extends B, implements some interface. I'm pretty much sure if you have worked on a code base or at least a huge code base, you would have seen such kind of code bases for sure. Now you would understand why it is created a certain way. Okay. All right, guys. Implement means what you're implementing. So you can implement an interface, you can implement abstract class, whatever that is. Okay. Implement just basically you define an interface. In that interface, whatever the properties, we don't call it properties in the interface. Whatever the values or schema that you've defined in the interface, that schema would be now created to this class. That's what you mean by implementation. So interface again is an entity. To implement that, either you implement it via another interface or you implement via an object. Okay. All right. Everybody clear with this? All the kind of relationship between the classes and the examples and the case studies and so on and so forth. Okay. All right. Let's move on to next part, abstraction versus encapsulation. And then we'll talk about some of the best design principles or programming principles. Let's go with abstraction versus encapsulation and take it from there. Abstraction versus encapsulation. Understand few things first. What is abstraction? What is encapsulation? And how are they relevant for us? These are also part of the object-oriented programming principles. When we say abstraction, what does that mean? In one single line, can anybody give me answer? What is abstraction? Come on, guys, be quick. Concept of data heading. What is encapsulation? One line. Wrapping up data in a single unit, not knowing details, so at least just okay, cool. Pretty much the same. Let's write it out. See, the word itself denotes it. So when you say abstract, means something is kept hidden, something is kept abstract, right? Abstract means, okay, let's take a very simple example. When you read any research paper, the first thing is written as abstract, right? Abstract means the summary of it. And then you have to go to the details of it to understand what it means. Agree? Just take a real life example. Let's ignore all the programming and anything. Just take a real life example. Any book that you read a summary or you read abstract, and then you have to go through the entire book or the novel to understand what that book was about. Same thing. When we talk about abstract, means we are just denoting the useful information. That's the first point of contact, which is denoting the useful information. We are hiding the internal details. That is what you call as abstraction. Encapsulation means the word came from capsule. Capsule is what? If you look at the capsule is just a combination of multiple ingredients. So in this case, we are combining multiple ingredients, which is data members and member function together, and we call them a class. That's what encapsulation is. Okay. Abstraction means data hiding. Sometimes it's called data abstraction also, by the way. Means you hide the implementation level, just expose the functionality to end users. Okay. You hide the implementation level, you just expose the functionality to end users. This is a design level. And how do you achieve that? You achieve it by abstract classes and interfaces. Okay, this is how you achieve. Cool. That is what abstraction is, or that is what data hiding is. When we talk about encapsulation, what does that mean? We combine the attribute and functionality into a single unit called class, so that data can be hidden or protected from the outside world. Okay. This is an implementation level. Abstraction is a design level. This is an implementation level. I'll talk about what is design and implementation. And this we achieve by access modifiers. Like either you make it private, you make it public, you make it protected. This is the way you encapsulate the values. What value should be exposed, what value should not be exposed, so on and so forth. Okay. All right. Who are end users are we referring here? Example in UI-based application. Guys, you can message to everyone now. Just quickly reminding you, the changing to message is only when I'm asking question to everyone. You have a question, feel free to share with other people as well. Then you can message to everyone. So to your question, who are end users? We are referring here in UI-based application and users the access to UI layer. End user can be anything who doesn't need to know the information. Okay. For example, I can give a very simple example. When you go to an ATM machine, you don't know how ATM machine works internally. All you know as an end user is you put your credit card or debit card, whatever that you put, you can do some transaction, you can get the cash out or you can submit the cash. That's all you know as a customer. That's you know as the functionality, what is of functionality of ATM. But inside that, obviously, once you put or chip in your debit card, it will first fetch your details. After fetching your details, it will verify the PIN. After that, it will try to see whether you have the sufficient amount that you're trying to withdraw, and all those calculations will go behind the scenes. Okay. So, and that will do the deduction, of course, from your account. So all those things go behind the scenes. You don't know that, and you don't need to know that. So you just expose the functionality, which is important for a user to know, nothing else from that. Okay. Now coming to the OOPS concepts, as we know, inheritance is a design level and it's implemented via polymorphism. Polymorphism is implementation level. Similarly, abstraction is a design level implemented via encapsulation, implementation level. Okay. So this was important to understand the difference between abstraction and encapsulation. As I said, abstraction means the data hiding. You hide the implementation level, you just expose the required functionality to the end customers. Okay. Encapsulation combine the attribute and functionality into a single unit called the class. This part crystal clear to all. Come on, guys, quickly in the chat. This part crystal clear to all. Okay. All right, let's move on to next part, abstraction encapsulation. Yeah, we just covered it, right? All right, next part, which is implementing code. One moment, one moment. Implement code, which include design patterns. Okay, I don't need to have the entire details here. This part. Okay, we're around 20 minutes. I'll target to complete this if you can, but may not be able to do it. But anyways, let's see whatever we can. Okay. Anyways, coming back. The previous question, did you discuss design level versus implementation level? You don't need to, but I just mentioned it for your reference. Again, it's a lot more theoretical discussion rather than implementing it, but just to tell you, what do you mean by design level, implementation level? What I specifically referred here is abstraction is an idea. Abstraction is a concept that we are going to hide something. How do you actually apply the abstraction? You actually apply the abstraction by using encapsulation. What do you mean by encapsulation? When you decide data members and member function, the first question comes, how do you hide that? You know that you want to hide some details, but question becomes, how do you hide that? Abstraction is a theoretical concept. How do we hide that is we create in a class, we create access specifiers, like something can be private, something can be public, something can be protected. So we will know exactly what piece of information I want to show it to public, I want to show it to protected, I don't want to show it to any other class. I agree. In a class, if you have access modifiers, you can decide what piece of information you want private, what you want public, what you want protected. So the whole concept of abstraction, how are you implementing that? You're implementing that under a class. That's why I said abstraction is a concept or a design. Encapsulation is an implementation. Same goes for inheritance and polymorphism. Okay. All right. Cool, guys. Let's move on to the next part now, which is implementation of code. Object-oriented to model real-world problem. We already did that, right? In the last class, we did object-oriented design to model real-world problems. This was when we talked about the difference of object-oriented design versus object-oriented problem. More we'll discuss when we go to the case study specifically. Okay. All right. In this part, when I say implement code, design pattern, solid case, and dry, I don't think we'll start with design pattern today because we have a lot more to complete that before. The first thing that I want to cover is before even we go to the design patterns is software design principles. Not solid. We are not talking about solid as of now. We'll talk it. Dry. Yes. No. Dry. Keep it simple and short. Yagni, etc. Okay. Some of you might know about this, some of you might not know about this, but I'm covering it here. Why I'm writing it here? These are very popular terms that you'll hear quite a lot from senior engineers, or depending upon whatever level they are. See, any kind of software that you write, there is no hard and fast rule how you have to write a software. Understand that first. You can write the way that you want to write. But that being said, as a software engineer or as a community of software engineer, there should be some standard set. It's not mean that you can write any messy code or you can write any spaghetti code. That's the term we use. So how do we avoid spaghetti code? How do we avoid writing a code which is not good as per the standards or as per the principle? Again, as I said, there is no hard code rules how you want to code, how you want to implement. It's up to the implementation of developers. But that being said, there are certain standards, there are certain principles. Those are called the design principles or best programming principle in general that every developer should follow. These are very basics and the bare minimums when you start writing code. A lot of people don't even focus on that while they are initially in their careers, initially in the sense like beginner or maybe mid-level, but once you become senior enough, these things becomes very important. It helps you in a good PR review. It helps you in writing a good code base or reviewing a good code base, so on and so forth. So you can look at the code base and you can understand the quality of the code base, how the code is written, how well the code is written. Okay. So as I said, these are just theoretical principles. All the examples I'm going to take here, all the references I'm taking there, all the principles that I'm talking about, I'm taking from the book Clean Code. So if you get a chance, read about it. There's a really good book by Uncle Bob. We usually call this Uncle Bob. It's Bob, and I forgot the surname. It starts with A or something, but we call this Uncle Bob. It's a very good book written late in IS 1997 or 1998, something like that. Okay. One moment. Yeah, let's take it at the end. It's a really good book, Clean Code. It's a Martin Fowler. Martin Fowler is one of the author. It was written by originally by Bob. Yeah, you can just Google about Clean Code. You'll find a lot of good books. It's a blue color book. You can find the Clean Code written on top. It's a good book for understanding the references, understanding some of the basic design principles. Okay. So software design principles, if you have to read, I would recommend reading Clean Code. Number one. And design patterns, if you have to read, I would recommend Gang of Four. Already shared those resources by the way. All right, let's talk about what are these principles, what are these usages that we do, and what's the purpose of that one by one. Let's start with number one, which is dry. Dry means don't repeat yourself. Okay. Dry principle says every piece of knowledge must have a single representation within a system. Every piece of knowledge must have a single representation within a system. Okay, that's just the theory, or that's just the statement for it. Now let's try to understand what that means. How do we achieve that? How do we achieve the principle of dry or don't repeat yourself? By creating functions and classes to make sure that any logic should be written only in one place. Okay, let's take an example to understand that better. So let's say I have a package A. In that package A, I have a class C. And that class C, I'm creating a function here, so on and so forth. Okay, simple. You probably would see in a code like this. Multiple times you would see in a code like this. Inside a package, there's a class, there's a function. Agree? So let's be quick. Okay. Now, what is the problem? Let's talk about what is the problem. Then we'll talk about what is the solution. Let's say in one package, inside one of the class, there's a function which is doing some job. Functions by default, they're supposed to do one specific job. That's why it is called function. Now there's another package B, and let's say that has a class D, and that has the same function definition here, which is clearly a duplicate. Agree? A very simple example I'm sharing here. A very simple example I'm sharing here. Let's say between two packages, and these packages are not aware of each other, by the way. You can take a very simple example. Let's say um, I need to write a function which creates a random numbers. Okay, maybe for something which is a UUID, I always need a unique identifier. So in package A, let's say this class C, I need a unique identifier input, so I write a function for creating a random variables or random inputs. Similarly, in class D also, I need a UUID. So what I did, I created an example or create a function for random variables. Now both these functions are doing the exact same job. But if you look at this in my code base overall, I have making this duplication of the efforts. Yes or no? Come on, guys, quickly in the chat. I've given a real life example. I'm pretty sure you would have seen this. If you have not seen this, you would understand this for sure. Multiple classes might require a unique identifier as input. I have this API, I have this API. Both API require unique identifier as my input. So I wrote a function in this API, I wrote a function in this API. A better way, what could have been a better way to solve this problem? Quickly in the chat. What could have been a better way? Correct. Let me write it if I can here. Let's say it's a function, and that function is random UUID generator, something like that. So rather than keeping that random UUID generator at each and every implementation, each and every implementation class, what I could have done better is inside my util class, I could have defined random UUID generator dot Java or whatever that is, interface class, whatever you want to do, totally up to you. And I could have coded like this. So from this or whatever it is, whatever location, import this, and then in my class C, bring it here, and then in my class D, I'll be using that function. That's it. This is just one simple example. So this is what DRY is, okay? Or don't repeat yourself is. So in terms of don't repeat yourself, if you go through a code base or even when you design a code base in general, try to segregate the specific values. Specific value in the sense, there might be functions which might be required for a lot of classes. Okay. So don't keep it specific to a class. Otherwise, you will need to rewrite the same function again and again in different classes, which is not a good practice. That's why we usually follow structure whenever you see a program. Just let me give a simple example. If you have seen any Java code base based upon Spring Boot or based upon Maven, depending upon whatever you have, you would have seen something like this. Give me yes or no if you have seen it or not. Let me write it down. There's something called controller. Then there is something called validators, utils, exceptions, and service. If you have seen this, tell me yes or no. Then I will add more details. DAO layer and all of this. That is, DAO is mostly for data access object. I'm not writing it here, but it's fine. Validators and utils will have the commons code, exception, whatever kind of exception you want. In service, you can have main or implementation, whatever you want to call, and then you can have test. This is usually the structure of majority of the project or the code base we'll be dealing with. Okay. Inside that, you will have the implementation classes, whatever that classes are. Okay. This is usually the structure looks like. You can go to any code base. Most probably you would have something similar to that. Why do we do that? What's the purpose of doing? The purpose is very simple. First, it helps us understand what part of code I look at. So if I have to say that's a very new code base I've never tested before, I'll start from where I'll go from the controller. I'll see where does the control comes into this particular package. So I'll read the main controller class. I'll see which function it is calling. Obviously, it will doing some validation check, some common element that I have to use. It will take it from the utility. Exception, already know what is exception, error handling and exception. And then I'll see which specific service it is calling. To go to which specific service, I'll go to the service code. That's it. So that's how you can become familiar with any new code base in general. So there is some kind of practices we follow. I'm not saying you have to code it like this. There's some kind of practice we follow which makes it easier for developers to work across, right? Same thing here. The first principle, which is do not repeat yourself. Find that piece of information which can be reused. If it can be reused, move it to a place where it can be reused rather than implementing in individual files. This part clear to all? Easy? Okay. Cool. Number two, curly law. Curly law just says one thing. One moment. Do one thing. Curly law means only one thing, which is do one thing. Okay. The multiple devs work on code base can duplicate the functions in different packages because they're unaware about it, how to deal with it. How to deal with it? Well, I think the very first thing is why they're unaware about it. There should have been a good documentation. Good document in the sense you can have a good README files or different documentation on the design part. So once they go through the code base, they know exactly what the code base look like and what part you're doing, what changes. That's part one. Part two, as part of documentation, there should be a KT session. So whoever is the person who is most experienced with the code base, who has a very clear clarity of the code base, just record a demo. This is the structure of the code and this is how we do it. Whenever a new developer starts working on it, they can look at this and they can go through the code base. I mean, the recording that you have or whatever that session that you have, they can understand what changes are required at workplaces that can avoid such scenarios. Okay. These are the only two things I think that you can do. Otherwise, you cannot stop anyone from committing a code. And of course, if you get a PR or something like that, then you can make the changes there. Okay. So you don't allow them to merge it. Rather than you can give some good feedbacks for the PR. These are the three things that you can do. All right. Now let's talk about the curly law. Curly law talks about just do one thing, means an entity. Entity can be anything. It can be a class, it can be a function, it can be an interface, anything. Should mean one thing only. Okay. An entity, either it's a class or it's a function or it's an interface, it should mean one thing only. It should not mean that one thing in one circumstance and carry a different value from a different domain in another circumstance. Okay. Now, this is the theoretical definition. I'll make it much easier for you to understand. Nothing much to discuss here. Pretty much what the word says, do one thing. What does that mean? Whatever entity that you're defining, usually the class is the function, the interface, they should be supposed for doing one job only. Okay. And their definition should not change based upon which particular circumstance you're using it. Example, if I have a payment class, the job of a payment class is to do the payment. Agree? However you want to define it, however you want to implement it, create whatever classes that you want to do. Yeah. Single responsibility, we mostly talk in terms of classes. That's what I'm talking. So I'm not keeping with single responsibility, but technically single responsibility is just an extension of curly law. That's it. Okay. Ideally speaking, any particular class, let's say you have created for a payment, it should be responsible for doing the payment only. Then it should not be used for some other information. It should not be used to send the notification. It should not be used to send um, let's say storing the user information, etc., etc. The purpose of payment class is to do the payment. That's it. Okay. That's what curly law is, more or less, which is again baseline for the single responsibility principle. Third is keep it simple and short. Keep it simple and short. The name is clear, and so is the definition. It talks about simplicity and extensibility of the code. Always remember, a good code is always a simple code, or a simple code is always a good code. Why do we write a simple code? Number one, it takes less time to write. Number two, so faster delivery time. Less chances of bugs. When you have easier code in the sense when you have a very simple code, it becomes very easy to debug it and very less chances that while you are coding it, you would have introduced few bugs. And next, and the most important, easier to understand. Debug and modify. Because as part of a team, when you're working on a code base, you're not the only one who's working on the code that you have written. There'll be multiple engineers working on this. So if somebody else has to understand your code, debug and modify it, that will become easier for you. And the quality of a good code is that, and that's the reason that we have a PR reviews. The quality of a good code is that how easily some other person who has not worked with you before, who has not seen your code before, who has not knowing what the context is about in the entire code base, can read your code and make a guess out of it or make understanding out of it. That's how you define a good code. Okay. So always write a code which is easier to understand. Anybody can read your code who have never worked with you before or never seen about what this code specifically is doing. They can read the code, they can understand what your code is doing. That is what you call as a good code. Okay. So keep it simple and short means easier to understand, debug and modify, less time to write means delivery time, less chances of bugs, of course, for testing as well. Okay, this part. All right. We are pretty much on time. Let's do a quick revision we have done. One example. One moment. We're pretty much on time. Let's do a quick revision for what we have done, and then I'll do. This is not done. We have few more things. In total, I have seven, so I'll cover the next four in the tomorrow session. Example for Carrillo, I said, in general, curly law, okay, when we go to single responsibility principle, it specifically talks about classes. Curly law speaks about generically. So any entity, be it a class, function, interface, it should do one thing only. The example I took was, if you have a payment class, the job of a payment class is to do the payment, nothing else. So it should not do send a notification, that should be sent via notification service. It should not store the data, that should be done by some other service. As part of payment class, the responsibility is to do the payment. That's it. Okay. All right, guys, let's quickly revise where we are and what we are doing right now. Just work in progress. These guys are done, 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 and done. Okay, let's quickly revise where we are right now. So we are at number 10, and then we have to go for the case studies. Design patterns and solid will take good amount of not three, 5 to 6 sessions. We'll take it from there. So today's session, first we start with the important part, relationship between classes. We talked about has a relation, is a relation apart from has a is a. Overall, four categories: association, composition, aggregation, inheritance. We talked about each one of them in detail. We talked about the Venn diagram. We took a real life example to understand all of them. And finally, we did a case study as well. Then we talked about abstraction versus encapsulation. We talked about data hiding versus how do you implement it. Finally, we talked about what are some of the best design patterns, or not design patterns, what are some of the best design principles we should follow while writing a good code. As I mentioned, I am quoting this from the example of Clean Code. It's a really good book. If you want to have a read, I would highly recommend have a read. First example, we talked about dry, which is don't repeat yourself. If you find a common code to be moved, move it to a common code. Okay, don't repeat it in a specific classes for that. This is generally example of a code base, and I told you the purpose of each one of them. Then curly law, which sets the baseline for a single responsibility principle. Every entity should mean one thing only. KISS, which is keep it simple and short. You write the code which is simple enough and extensible enough. Okay, helps to easily write the code, deliver it faster, less chance of bugs, easier to understand, debug, and modify. That's it for today's session, guys. Quickly give me clear if everybody clear with the revision. Any doubts, anything which is not clear as part of today's session, let me know. Clear? All right, guys. If everything is good, let's wrap up the session here for today. Let's catch up in the next session. We'll continue from there. Thanks for joining in. Have a good one.